Hey there, welcome to Pomodoro Joe for Thursday, November 9th, 2023. Today we're looking at LeetCode problem 1759, count number of homogeneous substrings. This is a medium problem. Alright, so we're given a string, s. We need to return the number of homogeneous substrings of s. Since the answer may be too large, return it modulo 10 to the 9th plus 7. And then it describes what this homogeneous substring is. A string is considered homogeneous if all of the characters in the string are the same. So it's just the same character repeated. A substring is a contiguous sequence of characters within a string. So that means all the characters have to be grouped together. They have to be next to each other. So let's take a look at this example. A, B, B, C, 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 A, A. All right, so each one of these characters can be a substring by itself. So that's A, B, B, C, all the way to A. So that means we have 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 substrings that are homogeneous because they're just one character and that character is the same as itself. So that's 8 right there. Then we have B and B. That's another one. So that's 9. And then we have these two C's. The first two C's, that makes 10. So the first two C's make 10, the second two make 11, and then all three make 12. And then we can group these two A's together, so that gives us 13. So we have 13 total homogeneous substrings. All right, cool. So let's put 25 minutes on the Pomodoro timer and we will get started. So for this one, we're gonna move fast. So let's see what we can do here. We'll have some result, we'll set it equal to 0, and at the end, we'll return our result. All right, so for this one, we'll start simply. We're going to have a start and an end index. So we're going to be going through our string one pass. The start index will start the current substring. The end index will be the index of the end of this current substring. And we'll just count how many of these characters are the same. So let's do that. So we'll have some start, set it equal to 0. We'll have some end, set that equal to 0. Now we're going through the entire string. So while start is less than the length of our string s. Now, I think we might be using this more than once, so let's get that out here. We'll call it s length or s len. So this is just the length of our string. All right, so now while the start is less than our string length, so first let's get our current character. So our current character, C, is just going to be the string at this start index. All right, now while we still have the same character, so while our string at the end index is equal to C, and while end index is still in range, and end is also less than our s length, then we can keep moving our end down further. So our result will increase by 1 because we found one new substring, and then our end will increase by 1 as well. We'll go to the next index. All right, so we're moving our end further down the line as long as this character is the same as our current character. Now when we break out of that loop, that means we found a new character or we're at the end of our string. That means we have some substring window here. We have a start index and an end index. So let's get the delta, the difference between those two indices. All right, now this might take a little bit of explaining, so let's see if I can draw a little diagram here. So we've just found some start index and end index for a bunch of characters. Let's just say it's A. So A. Now we have some start index. That's going to be here. Start, and some end index. That's here. Okay, so let me see if I can explain this. So now that we have the start and end index of our range, we can see that one unique string would be the entire list of these letters here. So that would be 1, 2, 3, 4, 5, 6. So this would be, these 6 A's together would be one unique substring. But we also know we could remove one, and that's also a unique substring. So that's 2, and then 3, 4, 5, and 6. So we can get 6 unique substrings this way. So this is a little bit difficult to describe, so I'm going to try this with a little diagram here. So imagine you have 8 A's. You found your start, you kept going down the line until you found your end, you found 8 different A's. So if you started at start and go to end, those 8 A's will give you one unique substring, or one homogeneous substring. But you can also get one, let's see, so all 8 will give you one. But then you can remove one from the start, let's say, and the remaining 7 give you a second one. And then you can remove another one, and the remaining 6 give you another one. So you can keep removing one A for each of these A's until you get down to one A left. So you can have 8, 7, 6, 5, 4, 3, 2, and 1. So that gives you 8 unique substrings. For one A that you remove, you get a unique substring. So you can remove up to 8 A's, you get 8 unique substrings. So imagine you anchor your endpoint. This A becomes your anchor. Now you can add one A for each one of these additional A's. So you start with one A, you can add 7 more A's. So that's going to give you 7 homogeneous substrings. 2 A's, 3 A's, 4 A's, 5, up to 8 A's. That's 7 substrings. So you start with that, 7. Next, you change your anchor point. You anchor at this A. Okay. So you had 7 unique substrings with your previous A. Now you're going to anchor with this A. How many A's can you add to this A? Well, you can only add 6 more A's, but you can add one at a time. So that's 6, 5, 4, 3, 2, 1. So now you have 7 more substrings. So what's the total here? Well, for every A, you can basically add the number of A's in that step. So you can start with 8, and then you move down to 7, 6, 5, 4, 3, 2, 1. So you can basically add the sum of all of those individual integers in the range from 1 to our delta here. All right, I'm hoping this makes sense. So what we want to do here is we want to increase our result by the sum of the range from 1 to our delta. So if we apply this to our example of the 8 A's, this will give us 1 A, and then 2 A's, 3 A's, 4 A's, 5 A's. Basically, this will take us from 1 through 7. Delta is 8, but this range is not inclusive. So you go from 1 through 7, and you'll sum those. So you'll basically get 7 to start with, and then you'll add 6, you'll add 5, and then add 4, add 3, add 2, add 1. So that's doing the same thing that we were doing with our moving our endpoints around. I'm hoping this makes sense. This is really hard to picture, and I'm not describing it super well. So now we've gone through, while our end is still the same character, we're going to update our endpoint. Once it's not the same character anymore, or we've run out of characters, then we find our delta. We can update our result by summing the range of our delta. And then we do need to reset our start. We're going to set our start now to our endpoint and start again. So start will equal end. And then we restart. All right, one quick thing before we do this. Let's swap this around. We want to check our bounds before we try to use them. So let's do this. While the end is less than the length of our string, and then we can use it, and our end is equal to our string at this index is equal to C. All right. Hopefully this works. Okay, seems to work. Let's see if we can pass all the tests. Wrong answer. Okay, let's use this test case. Now, the wrong answer here is not because we calculated wrong. Look how big this answer is going to be. It's because we didn't follow the instructions. I need to return this answer modulo 10 to the 9th plus 7. All right, let's do that here. 10 to the 9th plus 7. Okay, try this again. All right, passing that new test case. Let's see if we can pass all the tests. And we pass. And let's see, we don't do very well. We only beat 28% for 29% for runtime, 77% for memory. All right, let's jump back here really quick because there is something we can do. This was more of an example of how you could do this. You find the start and end indices, and then you calculate these different sort of permutations. They're not really permutations, different windows within our range. So this is one way to do it. There is another way to do this, and it should be faster. So let's do that here. Let's see, we don't need start, but we do need, let's see, we'll do this. All right, so for this one, we'll need to keep track of our previous character. So I still need this, starts as none. Okay, now for every character in our string, and if this character is equal to the previous character, so it's the same character that we just had, then we're going to keep track of our character counts. So our count here, I'll call it current count, will increase by 1. We have one more length of our substring. So let's have some current count out here. All right. Now, if it's not the same, so we have a new start for our substring, well, in that case, we have to reset our current count. So our current count gets reset to 1. We're starting out with a new single lettered substring. And then we do have to set our previous character equal to this character. Now here's the trick. At this point, we can take our entire current count and we can add it to our result. So our result plus equals our current count. So this is doing basically what we did with our loops, but it's doing it in a much more compact way. So in this case, we're going to keep track of our current count as we're going. So our current count is going to keep growing, 1, 2, 3, 4, 5, 6, 7. Now in our previous implementation, we would calculate that same range and sums by finding our start and end indices, and then we would add 1, 2, 3, 4, 5, 6, 7. We would sum that range. Now we're actually keeping track of our range in our current count. We're going to start at 1, it'll go to 2, 3, 4, so on and so forth, and we'll just be adding that entire, I guess, current count to our result. Similar to the way we did it with our range. In this case, we're just doing it as we go. All right, let's run this, see if this is any faster. All right, seems to work. Let's see if it's faster though. And it's significantly faster. So now we're at an 84% for runtime and a 30% for memory. So it takes a little bit more memory, but it is much faster. So this is definitely a better solution. All right, well, we are out of time, but I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.